In today's lesson we're going to have a look at triangles. Now, as you no doubt are well aware, a triangle is any polygon with 3 sides and 3 angles. So any shape with straight sides, 3 straight sides, we refer to as a triangle. The total or the sum of all 3 angles in any triangle, so in any triangle the 3 inside internal angles always add up to 180 degrees. Now, there's lots of different types of triangles. They don't all look the same, and we need some way of classifying them or naming them. And to do that, we look at the length of the sides and the size of the angles. Now, if I can just refresh what you've done previously, when 2 lines are the same length, we put a little dash on those lines to show that they are the same length. And we're going to continue doing that today. So if you see a little dash on 2 or more lines, you know that they're the same length. And we're going to do the same with angles. So any angles which are the same size, we're going to mark them with an arc. So if you see an arc on 2 or more angles, you know that they are the same size. So to classify the triangles, as I just said, we're going to look at the length of the sides and the size of the angles. So the first type of triangle we're going to consider is an equilateral triangle. So an equilateral triangle has 3 sides which are all the same length. So I'm going to put a little dash on all 3 sides because they are all the same length. Now, with an equilateral triangle, all 3 of the angles are exactly the same size. If you think back to what I said earlier, I told you that the 3 angles in any triangle add up to 180 degrees. So if we split that equally into 3 parts, 180 divided by 3 gives you 60 degrees. So that means that each of the 3 angles in an equilateral triangle are 60 degrees. So I'll put my arc on the angles because they're all the same size. And I'll write in the size of them. They are 60 degrees each. Now, there are lines of symmetry on an equilateral triangle. We mark the lines of symmetry with a dotted line. So there is a line of symmetry from every corner point to the opposite side. So there's a line of symmetry down the middle of the shape. Then if I go round to the next corner point, there's a line of symmetry from that corner point to the opposite side. And again with the 3rd corner point, a line of symmetry from that corner through to the opposite side. So 3 lines of symmetry on an equilateral triangle. So let's try and think of some ways that will help us remember the name of this shape. So it's an equal often suggests that something is the same. So an equilateral triangle is the triangle where all the sides are the same length, or alternatively, all the angles are the same size. So equal suggests that it's the same size angles, same length sides, then it's an equilateral triangle. Next triangle we'll have a look at is an isosceles triangle. Now an isosceles triangle has 2 sides which are the same length. So I will mark those with a dash. This side here and this side here are the same length. The isosceles triangle has 2 sides the same length. It also has 2 angles which are the same size. So we will mark those with an arc. So the bottom angle here on the left is the same as the bottom angle there on the right. And the isosceles triangle then has 1 line of symmetry straight down the middle. I can fold the isosceles triangle once so that one side fits exactly on top of the other. Now again, useful ways of remembering this. the I for isosceles, think about I for isosceles, you have two I's. So an isosceles triangle is the triangle which has two sides the same length, or alternatively two angles the same size. So I for isosceles, you've got two I's the same length, you've got two I's, and in an isosceles triangle there are two sides the same length. We will continue with isosceles triangles for the time being, but I want to make you aware that sometimes it's not always easy to spot with the isosceles triangles which two angles are the same size. You might look at a triangle sometimes and it might almost look like an equilateral triangle. So deciding which two angles are the same size isn't always that straightforward. It's not always the bottom two angles as I showed you in the previous slide. So what I want you to be aware is that where the two sides which are the same length meet, that is the odd angle out. So if we take this first triangle on the left hand side, the two sides are the same length, so this one here and this one here, they meet at the top. They meet there at the top. That angle at the top would be the odd one out, which means in this triangle here, these two angles are the same size. Take the next one, where the two sides which are the same length meet, so just here, this is the odd angle, the other two are exactly the same size. And I'm going to do the same with the next two triangles, so the two sides which are the same length are meeting here, so that's my odd angle out, and the other two would be the same size. Here, where the two sides meet, which is just this point here, this is the odd angle, the other two angles would be the same size. You don't always have to worry about this, it depends on how the triangle is drawn. And the scalene triangle then, the last but one, because we have got one more actually. So this one here, the scalene triangle, this is one where all the sides are a different length and all the angles are a different size and there is no lines of symmetry. So all the sides are different, all the angles are different and there are no lines of symmetry. And finally the right angle triangle. Right angle triangle is any triangle which contains a 90-degree angle. So this triangle here, if I mark this here as the 90-degree angle, if that was a right angle, 90 degrees, remember what you've learnt previously, the two sides are perpendicular, they meet at a 90-degree angle. And this one here, the 90-degree angle is in that bottom corner. Now, right angle triangles can be either scalene or isosceles. They will never be equilateral because think about it now, right angle triangle has to have a 90-degree angle, and with an equilateral triangle each of the corners or each of the angles are 60 degrees. So if I have a little look at the top one here, all the sides of the triangle are a different length, so I would refer to this as a right angled scalene triangle. Right angled scalene. And then the bottom one, I have got two sides which are the same length. So I'm going to put my marks in. Two sides which are the same length. So this is an isosceles triangle. So I would call this a right angled isosceles triangle. Now we can't be general here with the lines of symmetry because obviously scalene triangle has no lines of symmetry, but an isosceles triangle does have a line of symmetry, and I will mark it on this diagram here. It goes from the corner to the opposite side. So there could be a line of symmetry on a right angle triangle, but not always. So we've come to the end of the lesson. I just want to very quickly recap with you. Equilateral triangle, equal the same, all sides the same length, all angles the same size. Isosceles triangle, for isosceles you have two eyes. Isosceles triangle, two sides the same length, two angles the same size. Then we have the scalene triangle, that's the odd one, all sides are different, all angles are different. And then a right angle triangle finally is one that contains a 90-degree angle. Okay, that's the end of the lesson.